We are moving into demo number 5. Before we do that, I want to give you a chance to really organize a lot of the things that we wanted you to learn from this, because in demo 5, we're expecting you to be able to do most of it without looking at the teacher's work. So I want you to flip your packet over, or all virtual students, just make a new page on the bottom of this. Make and fill in this table. So we've got the 4 classifications. For each one, I want you to come up with what type of name would tell you that it's an element, and then how you draw the MOM diagram for an element. I'm not going to worry about states of matter right now. Same thing for compound. What would you see in the name of something that would make you think it's a compound, and then how you draw the MOM diagram. For heterogeneous mixture and homogeneous mixture, I want you to describe what would be present, and a little bit more to be able to distinguish between the two, and then draw a MOM diagram for it. For the heterogeneous mixture, we actually haven't drawn one of these yet, so you might leave that one blank, and that's fine. We can talk about that at some point in class. So do that, and then when you're ready, start the video again. So go ahead and pause it. So for demo number 5, we expect you to really be able to do a lot of this on your own, because so much of it are pieces you've seen before. So from looking at these images, you should be able to answer questions 1 through 6. I will help you out a little bit. So this hydrochloric acid, really what this is hydrogen chloride solution. So from that information, you should be able to identify what it is and then eventually draw the MOM diagram for it. We have zinc in this middle picture, and then we have the beginning temperature in this last picture. So go ahead and do that, and then when you're ready, keep going with the video. So draw them before MOM diagrams for the hydrochloric acid, which again, remember, is hydrogen chloride solution, and the zinc. And then when you're ready, move forward and you can see how we do it. All right, here we go. We have, starting out with our hydrogen chloride solution. So you have to think a little bit to break this down. So hydrogen chloride, you've got this first name, last name idea. That means this is a compound made of hydrogen and chlorine. So I'm using compound symbol. And it says it's a solution. So I've got my water, because when you see solution at this point, you can assume that it's dissolved in water. So I've drawn it. Again, the compounds are separated from the other compounds. Each is surrounded by water, evenly distributed. This is a homogeneous mixture, because when I look at it, it looks like it's all the same thing, which means that these particles or these compounds are evenly mixed up throughout. So every sample I take would be the same combination, or the same concentration. Then I have my zinc. Well, zinc is just found on the periodic table. It's not a 2-word name, it's just a 1-word name, and I can locate it. So I'm using a triangle, and I know it's a solid, so I made my triangles touching and organized. All right, let's see what happens. So this is the change we're going to put it through. So the zinc you're about to see come in, and we have the temperature going here. So as this is going, you can start recording in what you observe, like at the solution after the change. You'd be going to need to also record what goes on while this change is happening, because that's going to help us figure out how to draw the MOM diagram. And yes, it does take about a minute, but I will probably cut it off before the end. All right, so right away, you want to make some notes as to what you're seeing go on in the solution. Right away, we see a change. Also, keep an eye on the temperature. The last time we had temperature, I added the salt into the water, and there was no temperature change whatsoever. Now you can clearly see that there is a temperature change. So from this, we've got a couple things going on. You'll notice that there's a lot of bubbling. So that would be, you can write down bubbling as an observation. Whenever you see bubbles forming, that means a gas is forming. You can almost see it leaving here too. And then what we're going to do is, pretty soon you can hear a little bit of noise. What we're going to do is, there's a couple different tests 4 gases. One of them that we're about to do, we're going to take a match that is lit and bring it into the gas, and we will show you what happens. Make sure you have the volume up. We did that for safety reasons. We wanted to move the HCl out of the way. Here it comes. Cool. So cool. Let's do it again. All right, so I'm going to pause it there. The temperature would keep rising for a little bit, but it kind of tops out here at about 41. So that noise you heard, so we had a gas forming that caused fire to have a little tiny explosion. So like the one time in class we work with explosions. And so that actually might give you an idea as to what the gas is that's actually being given off. So then record the final mass, which is on the right side here, and the final temperature here. I'm actually going to, I'll just quickly fast forward it to the end. So there's your final temperature. Here is your final mass. And then you can see if you start looking at the masses and you compare them. So I'm going to give you, actually pause the video, then compare the masses and then come back. So the mass actually went down. The mass actually decreased. Well, again, we keep coming back to the idea of conservation of mass. So everything that we started with has to be somewhere. So we have visual evidence. Our observations told us that there was a gas leaving. The change in the mass is the mass of that gas that was leaving. The other information we know about the gas that was leaving is it caused a really tiny explosion from when we brought fire into it. So hopefully that can help you start figuring out what's going on. So I want you to think about all those pieces and draw a MOM diagram that has gas in it, and you can just put the gas at the top of the box. So you want to think about, okay, what might that gas be? It had to come from our the reactants we have, so you're going to use the same symbols. Then we definitely still have stuff in the beaker. Most of the stuff stayed in the beaker. There was only a small amount that left, so you want to think about what is still in the beaker. So I'm going to let you draw that and then start the video up again when you are ready to see our version of what happened. So here is what actually happened. So we had zinc chloride, hydrogen gas was actually what was leaving. So with the pieces, so we had hydrogen, we had chlorine, and we had zinc. Something there turned into a gas. Chlorine gas, that is a gas. However, it's also green in color and incredibly dangerous. And zinc gas, in order for the zinc to turn into a gas, that's pretty unlikely. You might not know that right now. That's fine. But hydrogen gas is something you've probably heard of, and hydrogen gas is explosive. So that is why it made the noise that it did. So then the zinc and the chloride, those two remained, and they're in solution. So eventually there'd be nothing left in the container except for a clear, colorless liquid. So let's draw that. So I said earlier in my diagram, the hydrogen gas was the square. So I'm going to show the squares leaving, even though there's probably some still left in the solution. Again, the model, I'm trying to show what has changed. What has changed is I have hydrogen gas leaving. And then zinc chloride. So since earlier I'd used the circle as the chloride and I'd use the triangle as the zinc, I'm going to bring those together and it's a solution. And I think we've seen a couple times exactly what that means. So I'm going to draw these in. And then we have our water. To make it a solution. So what we're going to, overall with these MOM diagrams, we're going to want to give you observations, statements of what is going on in a reaction and ask you to predict the MOM diagram for what changes are being shown. Some key ideas is that the conservation of mass has to hold. So whatever particles I start with, whatever shapes I start with, have to be the same shapes that I end with. I can rearrange the bonding. I can change what things are bonded to like I did in this one, but I can't all of a sudden introduce a new shape that wasn't there before. And then you want to think about, okay, what possibly is going on? Make sure all of your observations are represented. In this case, that gas that was leaving is represented by the gas leaving there, and then what's left behind is represented by my solution. All right, so last question. Again, you want to do the same thing we've done in the last question, use the same format. So what did I do? And then was it a physical or chemical change? And then give evidence. And this one has all sorts of evidence of what it was. And that concludes this. And then we will see you guys in class. And again, if you have any questions about anything, please email your teachers. We want to make sure that you have a clear understanding of this, because this is a lot of, we're going to use the modeling throughout the whole year in chemistry to help you understand what's going on in these solutions that we can't actually see the atoms.